Hello there. Today we'll be doing largest sum of non-adjacent numbers. Given a list of integers numbers, write a function that returns the largest sum of non-adjacent numbers. Numbers can be 0 or negative. There could be a maximum of 100,000 numbers in the length of nums. So in example 1, we see that there is a 2, 4, 6, 2, and 5. And by getting adjacent numbers 2, 6, and 5, we get an output of 13. And you may be wondering, what is a method to solving this? I'm going to be going over the brute force method. We'll be going over it by talking, and then we'll go over a dynamic programming approach, which is basically creating subproblems for us to solve. And I will thoroughly explain this shortly. So, in the brute force method, we can either have a 2 or 4. We can either start at a 2 or 4. And there will be an option for us to either go through and do a method where we have, let me just get some these, yes, pointers. And the 2 can either become a 6, or we can skip the 2 and get the 5. If we skip the 2 and we get the 5, we can get actually get to a 5 here. As for the 4, we can skip we can either do 2 or 5. So it's either 2 or 5 as possible. Of course, the maximum here is a 9, and after going through all of these paths, we will have a total of 13. Of course, you can see that as this the length of the array grows, we would have a huge issue with how large this tree would be. It seems to me that the tree is going to be at this rate like I would believe it's every time we have to create multiple splits for every, I guess, 2 items we encounter. So 2 to the n times. This is ridiculous. So we would use a dynamic programming approach to break this apart into subproblems so that we can solve this more easily at a O of 1, I mean not one time, O of n time. So how do we do this? Okay, so let's look at the original array. We have the original array here, 2, 4, 6, 2, and 5. Okay, this is the original array. And we have this particular item here. I started at 0, right? We have this particular item here called the first item. And let's start here. At this particular item, where could we start at? We could start at 0. We can definitely start here. And so we can get a maximum of 2. And next item, can we start here instead? Yes, and we can get a maximum of 4. At this particular location, 6, the maximum that we can possibly get is 2 plus 6, which is 8. So we looked at the maximum number 2 before our current number, and we made that our maximum number, which is 8, because between 4 and 8, 8 is bigger. Here at 2, we can either select 8, or we can select 2 plus 4, which is 6. 6 is smaller, so we're going to select 8 because by choosing the larger number, we can use we found that at this particular position the largest number is 8, and in the future when we look at this particular position and we skip the next few numbers, we can be assured that we can add the number that we want to this number and get our maximum number. So this is 8. And now at this particular case, at 5, we can see that by adding 5 to 8, we get a total of 13, which is greater than 8, and we select 13. Suppose we have another number like a 7. We would look at 8 and get a 15. So the number selected would be, we would have a, let's see, we have a 7, we have a 6, and we have a 2. Of course, this means skipping 2, 5, and 4. And so that is how we will do this particular problem. The way we will record these items will be R2. This is 2 before the current the house. The current item. R1 and R0. So by starting at R2, we can move R1 to be to 0 to 2, and make that our max of R2 plus this current number. So that would be would move R2 here. Wait a minute. I think we should move R1. No, wait. R2 makes more sense. R2 makes more sense because this is 2 before. And then, wait, no. R1 makes more sense. R1 makes more sense because this is 1 before and this is 2 before. Then we move R0 here, which is the 4. And we move R2 here, R1 to R0, and so on and so forth, until we get all the way down to 15. Let me just code it out. R1, R1, R2 equals 0 and 0 for num in nums. Let's see, R0 is equal to the max of R1 plus num, and R2 is the one that we want. R2 is 2 away, and R1 is 1 away. And we want to set R1, we want to set R2 to be equal to R1, and R1 to be equal to R0. That way we can keep shifting things along, and what we'll do now is we'll return R1. So as we will, let's run through the code one more time. So we're here at 4, and we move R0 to 8, this particular point. We find that 6 plus 2 is bigger than the R1, and so we move, so we set that R1 to 0 and R2 to R1, where R1 was. And we keep going. So R0 is now at 2. We check 2 plus 4 is going to be 6, and 6 is less. So we'll move R2 to R1 and R1 to R0, which is 8. And we keep going. So R0 is going to be 13. Because 5 plus 8 is 13, and we move R2 to R1 and R1 to R0. And by this shifting, we will get to 15 here, and we would shift R2 to R1, and we would complete our for loop when we finish all our numbers, which is here. As you can see, is a success. There is indented block issue. Let's see. Just need to move this. Run. Perfect. And we do a submission, and we are good to go. And that's our answer to this problem. The reason why we were able to solve this problem was because we broke down the problem into subproblems. At this particular point, we found that the biggest number that we could possibly get between selecting the previous number or this current number plus the previous, the biggest number possible 2 numbers ago was 6 plus 2, which is 8. Again, once we were here at this particular point, we were able to break down the problem to its sub-problems, where we find out, oh, look, at this particular point, what is the biggest item we could possibly get based on what we found earlier in the past, which was R2. And the biggest possible number at R0 currently would be 8, because we did not select any number, which is ignoring the 2, and so on and so forth. And there is so much more that you can learn by doing this problem yourself. And I hope that you enjoyed the video and that you learned something today. Please like and subscribe, and comment if you would like to know more about this problem. And thank you very much. You can find more of my material in the link in the description below. I will have information about what I'm doing in iOS and more algebra problems there. Thank you very much. Have a good one.